Here is lesson 20. This is all about volume. Okay. In lesson 15, we talked about a geometric solid as a three-dimensional shape. And that means it has width, it has height, and it has depth, now that we're in 3 dimensions. If we were to talk about maybe a fish tank, let's call this guy down here a fish tank. Maybe we can see in the top of it. And we have some water in here. The measure of the solid's exterior, the surface area, that would be how much glass we need to build the fish tank. The volume is how much water we can put in to the fish tank. Okay. Now, if this is just 1 cubic unit, that means it's 1 unit on all sides, height, width, and depth. Okay. So let's talk about our units. Now remember, just single units are used when we're talking about distance. Square units are used when we talk about area. And remember, the exponent tells us how many dimensions we're in, so units to the third power are what we use when we talk about volume. Here's our calculation for volume. Volume is always base area times how tall the solid is. Area of the base times height. Rectangular prisms, area of the base is length times width. Triangular, 1/2 length times width. And cylinder and trapezoidal, these are all the same base area calculations that we used whenever we were talking about surface area. Now, volume is really just about being able to do the calculations. So let's calculate here. I'm going to call my base area this side right here so that we can easily see it. So that shaded area is my base. So base is 4 times 3, which is 12. And the distance between the bases, or the height, is 2. Remember, volume is equal to base area times height. Well, B is 12, H is 2. Multiplied together, we get volume equal to 24, and in this case, feet cubed. I almost put feet squared. It's feet cubed. There we go. Alright, let's try this triangular prism here. Remember, volume is equal to base area times height. In this case, B is equal to 1/2 length times width. Here's our length, and here's our width. Since this is the same length, or the width is the same down here also. Okay? So we have 1/2, 3 times 5. 3 times 5 is 15, half of that is 7.5. And the distance between the two triangles on our triangular prism is 10. Multiply those two together, so we have base times height, which is 7.5 times 10, which is 75, and we're in millimeters cubed. Okay, let's go on to our trapezoid example. The base here has to be the trapezoid. Alright, so here's what we're going to do here. Remember, volume is base area times how tall it is, or the distance between the bases. B here is base 1 plus base 2. Notice how I'm using lowercase b's because these are not an entire area. This capital B stands for base area. These lowercase b's just stand for bases of the trapezoid. Divide by 2 times how tall the trapezoid is, not how tall the shape is, capital H, lowercase h, how tall the trapezoid is. Okay, B1 I'm going to call 7, plus B2, which is 3, divided by 2, times how tall the trapezoid is, 4. Okay, 7 plus 3 is 10. 10 divided by 2 is 5, and then we have 5 times 4, which is 20. Capital H, the height of the whole shape, is the distance between the two trapezoids. That's this right here. That's 9. Let's put it all together. B times H is 20 times 9, or 180 inches cubed. Couldn't find my unit there. Okay, Let's work on the cylinder now. Remember, volume is equal to base area times height. In this case, we have the base being a circle, so we have to find the area of a circle, which is pi r squared. Now we have a diameter of 10. Make a little note over here, d equals 10. That means r is half of that, 5. So we have pi r, which is 5 squared, so 25 pi. Capital H is the distance between the two circles, or the very obvious how tall this cylinder is, which is 50 meters. Okay, we're going to multiply this times this, because that's what our formula tells us to do. Base times height, so volume equals base, which is 25 pi times 50. Now, I am going to need calculator help to do this one. 25 times 50 is 1250 pi. And our units are meters cubed. Okay, there are 4 good examples of using a volume calculation. Now, let's go to the back page and try a more composite shape. Okay, notice on the back that we have sort of a rectangular prism, and we have half of a cylinder here. Alright, so what we're going to do is, well, first of all, looking at this, we're missing a radius here. We need a radius. So let's call the radius, let's call it 2 feet. That should be enough. Oh, actually, we didn't need that. It actually is 2 feet because it would be half of this diameter here. So we actually didn't need that, and being 2 feet is actually correct here. Okay, so the radius is indeed 2 feet. Alright, so we have the volume of this part here, which I'm going to call volume 1. The rectangular prism, and then volume 2 is going to be the cylinder. Remember, volume is equal to base area times height. So let's get the base area of this rectangular prism. That's going to be 2 by, let's go with the 4, which would be back here. So that side right there, which is touching the ground, that's what I'm calling my base area. So I got 2 times 4 down there for my base area. It equals 2 times 4, which is 8. My rectangular prism is 5 feet tall. So H equals 5. Let's put all this together for volume 1, which is equal to 8 times 5, which is an easy 40. Alright, now let's go after volume 2, which is a cylinder. Remember, volume is equal to base area times height. Base area in this case is pi r squared. Okay, so we have a radius of 2, so we have pi 2 squared, which is 4 pi. Now remember, we only have half of a cylinder here. Okay, so what I'm going to do is divide by 2 now to compensate for the fact that I only have half of the cylinder. That leaves me with 2 pi. I'm going to multiply that times how tall that cylinder is. Height is 5 feet. Okay, so volume equals base area times height. I got 2 pi times 5, which is 10 pi. Alright, now I need to add this and this together for a final answer. Volume total is equal to 5 plus 10 pi feet cubed. If you got lost on that one or needed to see something calculated again, make sure you watch this one again, because this is an important composite shape that we will see again. Here's probably the easiest one on the whole problem, or on the whole sheet. This is an example of an axle housing, and what's going to happen here is an axle is going to run through here and have wheels on it so that it can spin for something. The axle housing is to have the base area of 35 millimeters squared. So this right here, even though we don't know what this shape is, that has to be 35 millimeters squared. Okay, It is to hold an 18 millimeter long axle, which should stick out 4 millimeters on each end. So we got 4 millimeters on this end that we don't need, and 4 millimeters up at this end that we don't need from that 18 millimeter axle. We're going to subtract 4 plus 4 from this 18 to figure out how long this thing needs to be. So we got 18 minus 8, which is 10. So there's our volume right there. Remember, volume is equal to base area times height. Base area they told us, which was 35. And the height, we just figured it out, 10 millimeters. For a final answer of 350 millimeters cubed of steel to cast this part. If there was anything on volume that you missed or needed to watch again, make sure you go back and watch that part. And that concludes lesson 20.